Hello, mathematicians, and welcome to a new lesson. This is Mr. Garcia, and today we're going to be talking about the volume of spheres, hemispheres, and composite solids. This is a continuation of our last lesson where we covered volume of pyramids, cones, cylinders, and prisms. So if you haven't checked that video out, I strongly recommend that you do. So let's start, as always, with our objective. What we want to learn today, I can use given information and formulas to find the volume of spheres, hemispheres, and composite solids. So let's start by looking at the volume of a sphere. So if you recall, a sphere is a ball-shaped solid, and we know that the radius of a sphere is a line from the center of the sphere to any point on the surface of the sphere. We can find the volume of the sphere by using this formula. Volume equals 4 divided by 3 times pi times radius cubed. Now the formula is a little bit ugly, but the beauty of this one is that the only thing we need to find is the radius. So as long as we know the radius of the sphere, then we know what number to plug in here, and the rest we can just type it into the calculator to find that volume. So why don't we take a look at an example to see how straightforward it is. A regulation basketball has a diameter of 9.55 inches. How much air will it take to fill the basketball? So let's take a look at what we're given here. We know the diameter of this basketball is 9.55 inches. And we know they want us to find how much air it'll take to fill. So that means that they're asking for the volume. So let's start, as always, by writing down the formula for volume of our shape. So the formula for volume of a sphere, as we just did, is 4 divided by 3 times pi times radius cubed. Remember that this cubed means that the radius, whatever number that might be, we exponent it to the power of 3. So since we need the radius, let's take a look. We're given the diameter. So we know that the diameter is 9.55 inches. But remember that the diameter, from the diameter, if I divide it by 2, then that'll give me the radius. So my diameter being 9.55, I divide that by 2, and I end up with 4.775. So my radius is 4.775. Now I'm not going to round it yet. I'll round it down at the end. Right now I'm happy to keep my radius with 3 decimal points. Now that we know the radius, let's put that in our volume formula. So volume is equal to 4 over 3 pi times 4.775 cubed. So let's type that into our calculator. We'll start with our fraction, 4 divided by 3. We'll tap over here, move the cursor so that it comes after the fraction. So we're not typing this at the bottom or anything. And we have pi times 4.775 to the third power. Now here, I don't have a button that exponents to the third power. I only have squared, no cubed. But I do have this button that is a to the power of b. So if I tap on that, it's going to let me type in a number that I want to exponent this to. So I type that, and then I'll type 3. And now I'm raising my radius to the third power. So I've got my formula typed in exactly the way I wrote it. I press enter, and I end up with 456.05. We'll round that up because this number is bigger than 5, so we'll round this up. So my volume, 456.05. And that's the volume of the sphere. So now let's continue with the volume of a hemisphere. Now remember that a hemisphere is just half of a sphere. So to find that volume of the hemisphere, all I need to do is find the volume of the sphere and divide that by 2, since it's half of the sphere. Now we can come up with a formula for that too. Take a look. Now the volume of a hemisphere, this is our formula for that. We have the volume of the sphere, and we're dividing that by 2. But that makes it a little bit tricky because this formula is really, really, really ugly now, as if it wasn't already ugly before. But luckily for us, we can reduce this formula down a little bit more. Remember that if I'm dividing all of this, and I'll put this in parentheses, if I'm dividing all this by 2, then that would mean the same thing as multiplying this by 1/2, because dividing by 2 and multiplying by 1/2 means the same thing. So what that really means is that I end up with 1/2 times 4/3 pi r cubed. Now the two fractions that I have at the top in the front, I can multiply these two fractions. I don't have to worry about the pi and the radius cubed. When I multiply fractions, remember, we're multiplying the top here with the top there, and the top here with the top there. So I get 1 times 4, which is 4, 2 times 3, which is 6, and then I write the rest of this, pi r cubed. And so that's the volume of the hemisphere. Now, I can use this, but I can also simplify it further, and I'm going to do that. Because if I see 4 and 6, I know that I can reduce this fraction. So if I find the greatest common factor between them, which is 2, then I know I can divide the top and the bottom by 2, and that'll give me the reduced fraction. 4 divided by 2 becomes 2, 6 divided by 2 becomes 3. Therefore, our new formula for the volume of a hemisphere is 2/3 times pi times radius cubed. So this formula is a lot cleaner, and you see that it's very similar to the formula of our sphere. The only difference is that instead of being 4/3, like in the volume of our sphere, since we divide it in half, we have 2/3. Let's take a look at how we use this formula for a hemisphere. Mr. Garcia's mom made asada de puerco Nuevo León style. It's very delicious, traditional Mexican dish here. It's so good. She prepared it in a bowl with a radius of 14.5 centimeters. So there's some information that will be useful to us. Radius of 14.5 centimeters. And what is the volume of the bowl? Well, we know what a bowl looks like. In fact, a bowl is a hemisphere. So to find the volume of this bowl, we're finding the volume of the hemisphere. So let's write down our formula. We have V equals 2/3 times pi times radius to the 3rd power. So again, the only thing that I need to substitute in here is the radius. So as long as I know that radius, then I'm good to go. And in fact, I do know that radius is 14.5 centimeters. So in our volume formula, we're going to have 2/3 times pi times 14.5 to the 3rd power. And again, I can plug this into the calculator. I'm going to start with my fraction, 2/3. I move the cursor to after the fraction. Then I have pi times 14.5. I press this button to exponent to the 3rd power. And so we had 6,385.3. And there's our volume. All right. So let's move on to the next part. So the volume of composite solids. So composite shapes, remember that these are shapes, bigger shapes made up of two or more smaller shapes, two or more familiar shapes that we have. So solids is just a 3D counterpart to composite area. And just like area of composite shapes, composite area, there's 3 steps that we're going to apply here. First is we're going to break apart the solid into more familiar shapes. So whatever solid we start off with, we need to be able to identify if we can break it apart into more common shapes, easier shapes that we already recognize. The second step is to find the volume of each piece. So if I break this up into 3 shapes, then I know that I'm going to be finding 3 volumes. Say, for example, that I have a solid made up of a cylinder, with a cone on top. So if I have a cylinder with a cone on top, then I recognize that there's 2 shapes here, a cone and a cylinder. So I'm going to be finding the volume of a cone and a cylinder. But try to do these separately. Don't try to mix and match because you're going to get confused. Find the volume of the one shape first. I'll find the volume of the cone first. And find the volume of the other shape second. And it doesn't matter what order you do these in, but always do them independently. Finish one first, then do the other one. Finally, once you have the volume of every shape, add the volumes of all your solids together. So once I have the volume of the cone and the volume of the cylinder, I'm going to add those volumes together to get the overall total volume of my shape. So we're going to be taking a look at 2 different examples so you can see the process in each one and what we would have to do to find the volume of those composite shapes. Let's start with the first one. Let's read the question. Miss Humphreys got a new spinning top toy, which is made up of 2 cones together. So that information might be important. Let's highlight that. She measures the overall height of the toy to be 7 centimeters and the lower half to be 4 centimeters. She also measures the radius at the widest part to be 5 centimeters. What is the volume of the toy? So several things going on here. First of all, we have not seen this type of shape before in our lessons, but we do recognize that this shape is made up of 2 cones, one stacked on top of the other. So we know that there's 2 cones here. So that's the first thing that we have to do here is identify the shapes that we're working with. Other things that we know about this is that the overall height is 7 centimeters, which is listed here, and that the lower half, the bottom cone, measures 4 centimeters in height. We also know that the radius at the widest part of the toy is 5 centimeters. So if I imagine the circular base going this way, then my radius must be from the center here to the edge of the circular base, and we know that that's going to be 5 centimeters. So, and then we need to find the volume. So looking at this, let's highlight the 2 shapes that we have so we can identify them. Now we know that we have 2 cones. I know that the one cone is going along the top here. And we also know that we have another cone along the bottom here. So now we completed the first step. We've broken apart the solid into more familiar shapes. We have 2 cones here, and we're familiar with cones. We've seen the formula for cones, how to find their volumes, so we're good there. So now we move on to the second step, which is to find the volume of each piece independently. So since I have 2 cones, I'm going to be finding two volumes, and I'm going to be very careful to not mix these up. I'm going to focus just on one cone first, and then find the volume of the second cone. So let's start by finding the volume of the top cone first. So I'm going to write V top to represent the top. And I need the formula for volume of a cone. And I know that formula is 1 over 3 times pi times radius squared times height of the cone. So there's two things that I'm finding here that I need to substitute. I need to find what is my radius for the cone, and I need to find what is the height of the cone. Now the radius, remember that the radius at the widest part of the toy is 5 centimeters, which we've written in here. But we also know that that wide part right there represents the base of both of my cones, actually, because I have the top cone that goes all the way down to this lip, and the bottom cone stops at this lip as well. So this white part right here represents the base for both of my cones. So the radius of this cone has to be that 5 centimeters. Now for the height of the cone, for the top cone, I'm not given that height. I'm given the overall height, the total height of the toy, and I'm given the height of the bottom half. So I know the height of the bottom cone, but I need the height of the top cone. I need this part right here. But luckily, I can find that height because I know that if the total height of the cone is 7, and I want to find the height just up to this point, then I need to take away all of this. Take away so that I'm just left with this part up here. Now, if I'm taking away this part, I know that this part is 4 centimeters because these two lines match up. So I'm taking away 4 centimeters from the total height of 7 centimeters. So if I'm taking away, we know that take away means subtract. So I have 7 minus 4, and that gives me 3 centimeters. So the height of the top cone is 3 centimeters. So we can write that in. Now that we know the radius of the top cone and the height of the top cone, we can substitute those into our formula. So I have 1/3 times pi times radius, which is 5 squared, times 3. Now let's plug this into the calculator so we get our volume. And it clears that. We have 1 divided by 3. I put my cursor after the fraction, and I have pi times the radius squared times 3. That gives me a volume of 78.54. So 78.54 is the volume of the top cone. Now let's find the volume of the bottom cone. So because it's still a cone, I can use the same formula that I used for the top because that was also a cone. So I have 1 over 3 times pi times radius squared times height. And again, I need to find the radius of the bottom cone and the height of the bottom cone. Now be very careful here because even though both of these are cones, that doesn't mean that the radius here is the same as the top radius and that the bottom height is the same as the top height. If something does turn out to be the same, I need to be very, very, very careful and verify that it's supposed to be the same. For example, if I look at the radius of the bottom cone, I know that I need to find the base of the bottom cone. So it turns out that the base of the bottom cone is the same as the base of the top cone because they both have this circle here. So that means that the radius for the bottom cone is also 5 centimeters. Not because this is 5, but because they both share the same base. Now the height, on the other hand, the height of the bottom cone is 4 centimeters, not 3 centimeters. The height of the bottom is 4, and I can verify that from my diagram. So we always have to be careful and verify that these dimensions, we can find them in the picture, and if they end up being the same, then we know why they're the same. Not just because this is 5, but because they have the same base. All right, so now that we know that, let's plug it into our formula. We have 1 over 3 times pi times radius squared times height, which is 4. Now we can plug this into our calculator. We have 1 divided by 3. I move the cursor. Times pi times 5 squared times 4. I press enter. That gives me 104.72. So 104.72. And that's going to be the volume of the bottom. So now that I have the volume of the top and the volume of the bottom, the last step number 3, is we need to add the volumes of each solid together. So we have the volume of the top, volume of the bottom. We're going to add them together to get the total volume. So the volume of the top was 78.54. And we're going to add the volume of the bottom, 104.72. And if we add those together, 78.54 plus 104.72, we end up with 183.26. And if I look at my units, I'm measuring everything in centimeters. So my volume must be centimeters cube or cubic centimeters. And that's my answer. But I do want to leave you with this takeaway. Remember that to find the volume of these composite solids, remember our steps. First, identify the solid, break it apart into more familiar shapes. To try to see what other shapes can you see in our composite solid. Break it apart into those simpler shapes, and once you have it broken apart, find the volume of each piece. Remember to do this separately from each other. Don't try to find all of the volumes together at the same time, because you'll get confused. Do one first, then the other. And once you have all of those volumes, add them together to get your total volume. All right? So I want to leave you guys to go do your assignment. Okay? Remember to reach out to us if you need help. Please let us know. All right. So I'll see you guys later. Have a good day, great day, and always make good choices. You make your mistakes, learn from them. All right? I'll see you guys next time.